create a platform so that you will understand everything easily. Okay, so I think the slide is, I think, visible to everyone.
Yes,
So
sir,
now,
visible.
yes, okay, done. So first of all, it is very important to understand that what is IoT. So the definition, as you can see that IoT is basically you can say that a combination of various elements. You can say that a network of physical objects that are embedded with the sensors, software, and other technologies. In a simple language, we can say that the physical object is basically, we know that sensors, actuators, which we will discuss later on. So the things that connect, you can say that a system with outside environment,
अरे स्विच होता नहीं
right?
है
That is known as
आईडी मतलब
sensors and
जो वाली आईडी
actuators.
दोनों में लॉगिन है ना सेम आईडी लॉगिन है ना दोनों में
Okay, the combination of these physical
तो वहां पर
objects,
बोथ
network,
कंडीशंस फॉल्स
various
होती है ना
sensors, if there are 10
फॉल्स वाली
sensors, so the connection, that is that network of network of actuator, like motors,
अरे
okay,
ऐसा कुछ नहीं
and
होता है अरे
few
तुम्हारा
hardwares
तुम्हारी
like microcontroller,
तुम्हारी आईडी लॉगिन
and
है मैं
then
बता रहा
we will
क्योंकि
make a circuit,
क्योंकि
and if
क्योंकि जब तुम
we
अक्सर
will
नेटवर्क
apply
यूज
that
करते हो
circuit for a particular
तो
task,
तो तुम्हें
that will
इसमें
become
प्रॉब्लम
IoT.
नहीं आती है
A very simple example I can say that you have hear the word Alexa, Amazon. There is a in Amazon you can purchase one that Alexa device. That
ये साइन का
device
ऑप्शन
is
वहाँ पर नोटिफिकेशन
basically
ऑप्शन आ रहा है तुम जहाँ
use the
साइन पे
voice command, and
हेलो
according to my voice or
वहाँ से
according to
करो
that command,
वहाँ पे साइन इन करो
it will, you can say that, control the various devices, home appliances like
तुम्हारे
television,
फ़ोन में भी
like music system, like
फ़ोन में वही सेम
fan, like
सेम चीज़ है तुम्हारे फ़ोन में
uh, uh, LEDs, various things
चेक
we
करो एक
can
बार तुम्हारे
control
फ़ोन में या
simply
किसी में
by our voice.
ये हो सकता है कि
So
तुम्हारे
when we
फ़ोन
will
कोई और
speak
लॉगिन
something,
हो इसमें कोई और
so
लॉगिन हो
who will sense the voice? Obviously, there is a few sensors. So voice will be connected into electrical signal. This is basically the work of sensor. And if suppose if I want to turn on AC, so I will speak that please turn on AC. Then what happened? The sensor will sense the voice signal, and that signal will be converted into electrical signal, current and voltages, and that current and voltage will be given to microcontroller, who will give these quantities to microcontroller, the sensor. Sensors are basically convert the various, you can say that, signal which is available in the environment. Example, temperature. Sensor can sense temperature. Sensors can be used to sense humidity of soil. Sensors can be used as we have started with this example, voice. So various types of sensors are available in the market. So sensor is basically convert the signal which is available in the outside world into electrical signal, and that current and voltage signal will be given to microcontroller, and microcontroller will turn on that particular device which we want to turn. Let us suppose we want to turn on AC, so definitely you know that the compressor will turn on. So according to sensor output, the microcontroller will send signal to motor, and motor will rotate, and your compressor will turn on, and cooling will start. So this is the basic, you can say that, the first step of any IoT signal, any IoT systems. So, so the first is sensors. So physical objects, which is written in this definition, it is basically the combination of various sensors. An actuator is what? Yes, of course. Electrical signal code, that means a device that convert electrical signals into the, you can say that, physical motion. See, opposite of sensor. Sensor will convert the physical motion or whatever we are receiving from environment into electrical signal. Similarly, the actuator will convert the electrical signal into physical motion. So this is basically, you can say that, reverse process. So in IoT system, we will have sensors, we will have actuators, and then we will use some kind of, you can say, that microcontroller that control all the things. Then whatever the data microcontroller will send, if we want to store in a cloud, so we will store that particular, let us suppose the room temperature. So sensor will sense the temperature and it will send to microcontroller, and microcontroller will upload that particular room temperature into cloud. This will become IoT. This is the IoT. So simple, connecting various devices, exchanging data with other devices with the use of internet is known as IoT. But if I will ask you that controlling the TV via remote control, so the question is, can we say that this is the example of IoT? See, in a broad sense, everything that control, that minimize the effort, human effort, we can say that it is a part of IoT. So it is, you can say that, you can say, sir, it is because internet is not available in this controlling of television via remote control. Internet is not there, so we cannot say this that IoT system. But there are various types of protocols available, like Bluetooth, which does not require any internet, like Wi-Fi, we can send data. So exchanging data can be on any platform, right? So basically here we are talking about the exchanging data between two devices, right? So yes, it is, you can say that, we can say that in a broad sense that it is an example of IoT. Now we are moving towards the next. So look at here, the applications, so where we can apply. So we have understood that, a brief, that what is IoT. So sensing something, and according to that sensor, controlling something and store that particular data into cloud, we can say that it is basically the IoT. So now question is, uh, where we can use this IoT system. So in India specifically, or anywhere, but specifically because in India we have so many problems, real-time problems. So generally we will talk about the Indian conditions. Okay. So the IoT applications, you can see that the first and very, you can say that we have seen this application in various places like smart home. So right now we want to control all the home appliances through internet. Okay. So now there is a geo fiber cable. So we have a high speed data. Okay. And definitely there are, I have taken one example like Alexa that will control various devices. So smart home means everything should be controlled by, it will be controlled by internet. So we can say that this, you can say that one of the good example of IoT is a smart home. Similarly, smart cities. Is in smart cities, in Bangalore, many places have pay and parking system. Okay, and how this system will work, I will explain you. So many places, what happen? Uh, they will have one app. So whenever we want to go any mall or anywhere, uh, using that app, we will book the parking slot before. That means in advance. So we will pay and we will book one slot. So when we will go to mall, okay, the vehicle will be parked, okay, and you can say that after few hours, that means when the timing will be finished. Let us suppose the parking is available for 6 hours. Just before few minutes, through that app, the the particular, you can say that, management will send the warning message, just maybe just 10 minutes before, by saying that, you better to renew your you can say that that parking slot, otherwise you have to pay fine. Now this is the very good example of IoT. In Kanpur we do not have such kind of system, but in smart cities this is one of the, you can say, that good example of IoT, because it involves so many, you can say that various things. There is a connectivity between various you can say that you can say that devices. Maybe there is in a parking there will be some kind of RFID which will sense, okay, something, okay, so like this. Anyway, so this is one example. Similarly, in small you can say that small industries, yes, of course, industries, we have various examples in industries, okay, in which we can use the IoT and make the system, you can say that, more flexible. Healthcare system, a example we have seen of that is the example of IoT in you can say that recently, that is the, you can say that, the COVID management. You have seen that a minute after we get vaccinated, we got one message that you are vaccinated, and everybody felt this system. So what happened? So when we will get vaccine, the nurse will press button, and we will have a message on our mobile. So this is a, you can say that a best example of that is IoT in healthcare system. Many more things we can make in healthcare system to make system more advanced. Let us suppose we can store the data of any patient, okay, of last 4 or 5 years, and on the basis of that, doctor can prescribe, you can say that that medicines, okay. So this is the very, you can say that, a broad you can say that class of IoT. Similarly, in agriculture, you know that we can have a sensors like that is humidity sensor, which can sense the humidity of soil, and according to that you can say that output, we can make a decision that whether the water is required or not. So like this in agriculture system, as well as we can use various IoT. It is basically the application of IoT. Now we are moving towards the next slide. So this is just for your, you can say that, knowledge, that IoT architecture will basically consist 5 layers. So actually I have not included that business layer in this layer, because this is the, you can say that, optional layer, because if we want to make a system in a business purpose, then business layer can be, you can say, involved. So basically let's start from the perception layer. So you can see this perception layer. So perception layer is basically deals with physical objects like sensors, like actuator, like RFID tag. Okay, you have seen in metro stations there is a RFID tag. Okay, there is a coin that will consist some kind of NFC protocol. Okay, NFC protocol, near field communication. So what happened when we will put that coin near that system? Okay, suddenly then the door will open. So these kinds of sensors, tags, actuators, the study of all, you can say that, these physical objects, the connectivity, number of pins, how we can at which voltage these sensors will work. So many things we should know during the, you can say, the design of IoT. So the perception layer basically deals with this physical object, and once the physical objects will be you can say that we will understand the physical object that clearly, then we will move towards the transmission layer, in which we will use to send the information. Okay, so for that let us suppose we can use a Bluetooth module, or we can use a Wi-Fi module. So we will discuss all these things in detail, but these are very simple things we should know. So that's why I am explaining Okay, these things. Okay, so that transmission layer, or then this transmission layer deals basically with the information transmission. As I have told you, that various modules we can use that can send the information of sensors and actuators into the air. The third one is middle wave layer. Okay, that layer is basically if we want to store cloud. Okay, let us suppose there is a, you can say that in Vijayanagar Choraha, and there is a traffic. Okay, so if you want to store some data that how many vehicles come during the peak hours, like for example, like in the morning 9 to 10, and then you want to make a database in which you want to store that how many vehicles, what is the density of traffic during the 2 to 5. So if you want to make a system in which you will store that particular database, and then you will analyze, and according to that you will make a circuit which is smart, adaptive. So see, so that is basically the, you can say that middleware layer in which we will store something, and after that we will analyze that, or you can say that we will apply that particular, you can say that, data, like in application layer. So application layer comes after this one. So whatever we will store in a cloud, okay, we will apply that database, we will analyze this one, and then we will use we will use these data to make system more smart. Okay, let us suppose we know that the traffic is more during the peak hours. So what we will do, so we will make a system in which the red light, green light will turn on very frequently, right? Maybe it may possible that the vehicle which are coming through Jharib Chowki, the traffic density is more in that particular direction. So we can make a system in which the green light will turn on for few more seconds in this particular direction, and when the light will turn on from like from your Barra to Vijayanagar, so that particular light signal should turn on a green signal for a, you can say that, less than few seconds. So according to that comparative study, you can make your system smart. So this is basically the overall, you can say that, power of IoT. And if we will make a product based on all these things, and we will utilize that one for business, so definitely okay, definitely it will comes into the business layer. So we are not going to discuss too much on this, because these are very, you can say, the theoretical points. We are here to understand the, you can say that, a practical aspect of IoT. So we are going to move towards the practical aspect. Okay, so now next slide we are moving. So see, this is basically, you can say that, the explanation what we have understood this that perception layer and network layer, application layer. So you can see that the problem with perception layer is gathering the right kind of data at desired level. And that is the important point. Perception layer is basically, that it deals with sensors and actuators, but it may possible that sensor is not of good quality, and the data that we want from sensor, okay, uh, that may be not reliable. Okay, so it is very important to understand, to study this perception layer, because this is the basic building block of, you can say that, IoT. Similarly, the challenges that occurs in network, that ensuring the reliable communication without much retransmission. You have if you will make a few project in which the Bluetooth module is involved, you will see there is a general problem in which you will make a circuit in such a way that whenever there is a LED blink, okay, the message should be sent to any mobile. So what happened during the coding, you will see that there are problems of retransmission. That means the message will comes various times. So you do not want, if you are making system, okay, a real time system, right, for any business purposes. So we have to understand that reliable communication without much retransmission is required. Similarly, that the application layer. Okay, so application layer, and now we are moving toward the next part. So see, I have explained all the things. Okay, so cloud computing. And one more thing I want to introduce, that that the question student can ask, that sir, how we can you can say that identify the traffic density. Let us suppose in different language I can say, let us suppose in one direction there are 50 vehicles, and maybe in another, that is from south direction, maybe the number of vehicles is 500 example. So the traffic density is more in that. So how we can understand what are the components that we can use to understand that the traffic density? So for that you have to understand the signal processing, image signal processing, image processing. So you have to work on image processing. Okay, so there will be some sort of camera that will capture the image, and in that particular image you have to use the image processing. So in this field you have to work, you have to understand image processing, and then you can analyze various things, and according to that you can find out the traffic density. Okay, now we are moving towards the physical components of IoT. Now slowly we are moving towards the project part, you can say that the practical session which we will discuss. Okay, so IoT have, you can say that, various elements. One element is embedded system. You know that microcontroller, sensors, and actuators, all these things will make embedded system. And embedded system is a very important part of IoT. And after that there is a wireless sensor network, means whatever we will receive from this embedded system, we will store that into cloud, or in wirelessly we will transmit in somewhere. Okay, so that will basically the another part of IoT, in which we will store the things, we will transmit wirelessly. That was another thing. And the third one is obviously we will control system, means whatever we are receiving into the cloud, we will analyze that thing, and according to that we will control few things. Okay, and then last we will apply. So now in 3 days session, in this workshop, 3 days workshop, we will focus on first element of IoT, and that is basically the embedded system. So embedded system, we will work on, and we will understand various sensors, microcontrollers, everything. And in the next, you can say that IoT workshops, okay, we will understand that how we will store these data into cloud. So the cloud part, or next element of IoT, we will understand in the next workshop. So here in 3 days, we will understand everything about the sensors, actuators, microcontrollers, like this, the first element of IoT. Okay, so now look at here the slide. You can see that a sensor is a device which sends something from environment. It may be temperature, it may be pressure, it may be humidity, various things, and passes that information to processing unit in the form of electrical signal. Understood? In the form of electrical signals. So what is the processing unit? Processing unit is basically the microcontroller. Now the sensors are basic building block of IoT. We have already studied this thing. Now what are the types of sensors? So general that sensors that we will have, that is a RFID tag. You know that in all ID card we will have that RFID card which will store the information of any person. Then we will have infrared, you know that, through which we can send data. GPS module we will have in our, you can say that, a system. In all mobiles we will have GPS tracking system. So it will, again, it will be, you can say that, communicate with satellite, and according to that the output will be given to processing unit. Then there is a sensors like temperature, humidity, pressure, and etc, etc. So just opposite of this sensors, we will have an actuator, means whatever we have received in the electrical signals, that should be important, that should be converted into physical movement. Let us suppose we want to, you can say that, run some kind of device like robot. We want to move one hand to other hand. So robot hand will move via motor. So motor will be controlled by actuator, means the electrical signal that actuator will receive from microcontroller, that will be converted into physical motion and your motor will start running. So it is very important to, you can say that, analyze that electrical signals. Like you have seen that stepper motor, servo motor, various motors. We will study in the next session, that is tomorrow, servo motor and DC motor. So various motor we will see. Now, so now we are, as I have promised at this in the starting of this session, that the focus of this session will be basically on, you can say that, project, or you can say that any, you can say that, practical aspect of IoT system. So here is the outline. So first we will understand the microcontroller board. So we are basically use the Arduino board, and there is another kind of board which is very powerful board, that is Raspberry Pi. Okay, so we will see the picture and we will discuss that Raspberry Pi later on. Then we will understand that Arduino IDE. Our Arduino IDE is basically a software in which we will perform a programming. We will write something. We will write a program and then we will upload that into microcontroller. And then we will understand the Arduino programming, because today in the last half an hour we will program our circuit and we will run our circuit. So Arduino, the programming, we will understand few aspect of Arduino programming. And this is very important, that ESP8266 Wi-Fi module. This module is basically, you can say that, it will basically provide the network to your board, because Arduino board cannot send a data into cloud. Okay, so ESP8266 is basically a Wi-Fi module, and if we will connect this module in a system, then you can connect any Wi-Fi you okay network to Arduino circuit. Okay, so now we are moving towards the next part. So look at here. Now I am starting the microcontroller part. So look at here. So this is the that is boards on which we will do all the programming. So this is Arduino Uno. Various version of Arduino comes into the market. Okay, so this basically the chip that you can see, it is basically the main part of your Arduino Uno, and this is a microcontroller of Atmel series, and this basically provides, we can say it is a processing unit. But this Arduino cannot be, you can say that, send a signal into cloud or any data into cloud. So we need ESP8266 module if we want to provide internet to this Arduino Uno. Similarly, in the next session, that means maybe in the next workshop or maybe next to next, we will discuss this Raspberry Pi. This basically known as a mini, you can say that, computer. Some people say this is a mini. It has a various, that is, it is an advanced version of Arduino Uno, and yes, various things we can do with the help of this Raspberry Pi, a very strong that is IoT hardware platform on which we can make IoT projects. Now this is the example. This is the example that we will see, and we will try to make a project to solve the issue that you can see on this image. So first of all, it is important to understand this image, what this image says. So in image, you can see that one person is moving on the street, and you have seen that various lights is turned on, which does not require actually, because only few, you can say that lights, whenever the person is moving on the street, I think the lights which is very near to that particular person, it should be turned on. Okay, but here in a picture you can see this just a vestige of, you can say that power. Okay, light. So you know that you have to make a very, you can say that project or a system, IoT model, on which you can save the power. And how you can save the power? The answer is that if there is no person on the street, that light should be in minimum brightness. Okay, because it is a on the street, so it is very important to have light, but there should be a minimum brightness so that the power consumption will be less, the first thing. And if there is a person on any vehicle is moving on this street, that what happened? So the lights which are very near to that vehicle, it should turn on. Okay, means brightness should become a maximum, and when it will cross that particular street, so it should again will be the minimum. The brightness should be minimum of that particular street light. So if it happens, so what happened? The all the lights which are on this street will be in minimum brightness whenever there is a night, and whenever the person will cross this street light. Okay, so these lights will turn on with the maximum brightness. So the objective of this today's session will be, we will make a project in such a way that whenever any person will be detected, okay, so tightness should be maximum, otherwise it will be minimum. But the condition is applied that the environment should be dark. That means in the daytime there should not be, that means all light, whether the person is going crossing that street or not, it does not matter, the light should remain off. But if the but during the night, when the, you can see that normal natural light is less, then the light should automatically turn on with the minimum brightness, and when person crosses, the brightness should be maximum. So I have explained so much about this problem, and we will try to resolve or solve this problem via one circuit. Okay, so now before we will enter into this, that is the project part, and we will start analyzing, we will start making a project, and we will do all this practical aspect. Okay, it is very important to understand the problem. So problem I have already explained you. Okay, I got one message first of all. Yes, okay. So now, so this is, you can say that, so again, I am repeating, if you have any doubt or if you have any question, okay, and if you want anything, okay, you can write on a chat box, okay, and I will read that one, and according to that, we will that is schedule the workshop in the next time according to your suggestion. Anyway, let's start. So you have seen this previous image, and this is the problem that we are going to resolve. And the problem is that street light lamps glow even when not required, leading to wastage in electricity. I have told you the use of IoT, Internet of Things, can help us in building an adaptive system. Adaptive system means a system that will adapt itself according to circumstances, right? So we are going to make a system, adaptive system, for these street lamps in a following manner. Step number one, what will be the condition? The first condition is that all lamp has to dim when there are no people around. This is the first condition. So we have to make sure that light should have a minimum brightness whenever there is no person. Second step, there should be a maximum brightness. That means all light, see, maximum brightness, that means if we are under one street lamp, so that particular street lamp should have a maximum brightness So when a person or any vehicle is around that lamp, this is the objective second. And the third objective is the lamp must turn minimum ambient light automatically. Means, let us suppose this is a cloudy nature. The light is, you can say that natural light is very having a less intensity or brightness. So there should be a system that adopt this environment. That means adopt the situation of environment. That means if there is a cloudy nature, cloud, so the light should automatically turn on with the minimum brightness according to light intensity. Understood? So these three things we will focus while making a project. Okay, so now the next thing, next slide, you can see we are okay. So before going to make a program or project, it is very important to understand few points of Arduino programming. So if you don't know, so please understand and listen my words carefully, because we are going to use these codes or these programs while making a project. Okay, let's start. So this is the Arduino IDE platform. That means whatever we want to make, whatever we want, that means connect any sensor. Okay, so we have to make a program, and according to our program, your system should work. Making a system is very easy, but to make system according to us, we have to use this. Okay, my one question is coming that can we use, sir, we use a sensor that will sense the presence of person so that it control. Yes, this is a PIR sensor which we will discuss today, and this will sense the presence of person, or you can say that, and it will control according to that. We will control the brightness of lamp. We will do this thing today. Okay, so wait for a second, few minutes. Okay, so this is two. You have seen that on the screen there is a white setup and there is a white loop. So in a C programming, you have basic idea about, okay, what is loop and what is the real meaning of setup. So white setup means you are initializing something, you are setting something. Let us suppose I am taking one example. You are going to make a project, okay, in which there is a counter which will count the number of students inside the classroom. So you will put one sensor, and that sensor will sense whenever the person will enter inside the room, it will count one. Okay, so the point is that that okay, so the point is that it is very important, and you want to write one text that one person entered in the room. So who will write this thing on the screen? Microcontroller. Example I am taking. Let us suppose I am speaking something. Suppose I am speaking like, welcome to this workshop. Okay, I have used this word welcome. There is some sort of speed of data transmission. Means I am speaking something, that means I am sending some data with some speed. Example, if I am sending 2 bits per second, okay, and your receiving speed is 1 bit per second. Please, I am repeating this thing, then only you will understand setup. As a transmitter, I am sending 2 bits per second, but this is the transmitter speed, but you are receiving 1 bit per second. This is your speed of reception. After 2 seconds, you will receive only 2 bits, but I will send 4 bits. There is a loss of 2 bits, means loss of information. So it is very important that transmitter speed and reception is the person, the receiving speed should be same. So that is we will do in void setup. This is one of the example. That means it is very important to initialize the speed of data transmission, and it will be transferred to both devices, transmitter as the receiver, that the speed of transmission should be this only. Then the reliable communication is possible. Understood? So void setup means we will do all these things, we will write all these things in this void setup. Means what will be the speed of transmission. Second example I am taking, and then I will that means it will be completed with void setup. Second example, please listen. You know that your ears, through your ears, you will, right now you are listening something, okay, and I am speaking through my mouth. Understood? So for my brain, this mouth like a output terminal, because through mouth I am speaking something. Clear? So for me, for my brain, it will output device. Like you have seen in your laptop, okay, there is a screen which is output device. You can see that one. And similarly, through ears I will listen something. Means if you will speak something, I will listen. So for me, for my brain, ears are a input, you can say, device or terminal. So every brain or every CPU, it is very important to say ki, from where the data is coming and from which terminal data is going. If my brain will reverse the process, please assume this thing. If my brain will reverse the process, this that means my ears will start become output. Means we have to say something, that you have to use ears, and similarly the mouth will become the input. That means you cannot speak, that will become an input terminal. Now you know that we cannot speak anything, it will be, you can say that, finished. The brain will be finished. Okay, the problem is that because we cannot communicate properly. So it is very important initially, because in microcontroller there are so many pins. So at which pin we are connecting sensor, because sensor will send data to microcontroller. Understood my point? Sensor will sense from environment and send data to microcontroller. And it is very important that, let us suppose sensor is connected to pin number 1. So for microcontroller, that pin should be the input terminal, because microcontroller has to receive something from one. So this is basically the we will do in void setup. Void setup, we will provide all the setups of program. We will say that these are the inputs through which you can connect sensors. These are the output terminals through which you can connect motor, LED, bulb, etc., etc. Because the microcontroller, you have to, you can say that, tell microcontroller that these are the output terminals and these are the input terminals. So the input terminals we can connect sensors, and output terminals we can connect actuator like motors and LEDs. Finished. And more explanation, the you can say that next point. Void loop, if we want to run any, you can say that, program for infinite times, we will put in this particular loop. Later on we will discuss while making a program. Now we are moving towards the next part. Okay, so next slide. So this is a very, you can say that, basic, you can say that, 4 steps through which the program will be performed. So the first will be, definitely we will write something that will call the editing part. Then we will compile, we will see is there any error or not, or you can say that successful complete or successful. If we will compile anything, that means we can upload that particular code into a microcontroller, that we will upload that one, and after that we will run, and we will see that the system will start working. So these are the 4 steps of Arduino. Now, another thing is that, okay, so we have discussed this one, okay. Now, setup and loop, we have already explained this one, the initial segments of code, okay, and the loop, the section of code which we want to execute for infinite times, we will write in the loop, okay. This is the microcontroller that we are going to use, and in that microcontroller we are going to make a program. Okay, so I have told you that in the last 1 hour we will make a project, and we will try to make 3 projects. Okay, so we will use this microcontroller, so it is very important to understand this microcontroller board. So first of all please try to understand that these are the pins. Okay, wait. Okay, yes, so this is your microcontroller part, right? This is the reset part, and this reset will basically, that the real meaning of reset, so whatever the program is going on, this pin will reset. So whenever we will send any signal, it will reset and the program will start from the first step. This is the 3.3 volt. Now 3.3 volts. So whenever we want 3.3 volt for any module, okay, let us suppose there is a sensor, like I have told you, ESP8266. So we will use this 3.3 volt. We will, so here whenever we will provide that is power to Arduino, what happened, 3.3 volt we can measure using the multimeter, and we can use this 3.3 volt if we required. So we have discussed the Wi-Fi module ESP8266 that will work on ESP 3.36. So we will take from here 5 volt, which we will use today. So if we required a 5 volt supply, if any sensor will turn on 5 volts, so we can take from here. So this is the, you can say, that board which have various, you can say, that pins. Now this is the ground pin. Okay, so that the ground pin, everybody knows the concept of electrical. So there will be a complete circuit, then only the signal can be transferred. Okay, these are the analog pins. So I am, you can say, explain a very, you can say, that brief introduction of this, because we need some practical, we have to move fast on that particular segment in which okay, we have made one, you can say, that problem in the previous slide. So we will discuss only those things which is required for today's, you can say, that project. So these are the analog pins. So analog pins are used uh, whenever we want to send analog signal. Everybody knows what is example, your temperature maybe 25 degree, maybe 25.4, maybe 23, 20, it should be anything. Okay, it is not a digital quantity, it is 24, 18, 16. So the temperature sensors will send the signal into analog. So through this analog pins we can connect. These are the PWM pins, pulse width modulated pin, which we will discuss tomorrow. Okay, the pulse width modulated, and we will connect servo motor through this one. Okay, these are the digital pin number 8, pin number 7, then pin number 6, where we do not have any kind of, you can say, that symbol. That is a digital pin, means this microcontroller will send either 1 or 0 to these pins whenever we will make any, you can see, that program, right? Similarly, pin number 2 is also a digital signal, and similarly pin number 12, pin number 13. So these pins are basically the digital pins. Okay, so whenever, see, we know that according to, whenever we will make any statement, or we want to make any program, so we will understand the sensors, that which kind of sensor is okay. We will understand, we will read the data sheet, and according to that we will understand it is an analog sensor or it is a digital sensor. So according to that we will use these pins. Okay, so I have explained this one. So these are various things for, you can say, serial communication. Various things are we can do with this Arduino board. So right now we do not have, you can say, that enough time to explain everything. So simply I have told you these things, and we will utilize these you can say that concepts in today's class. Okay, so now we are going to move next. Okay, next slide. So now there is another syntax. Okay, like you can see. So now please understand, next 2 or 3 slides, uh, if you will understand that, everything will become very easy and you will understand all the things. Okay, so pin mode. So here you can see that we will have a pin mode. So this pin mode syntax is basically used to set input and output pin. Means pin mode. Okay, I will explain this thing by that Arduino board. Look at here, this is. So now here you have seen, let us suppose I will connect any, you can say that, led at this particular. Look at here I have connected this led. Now what happened, that means the microcontroller, if we want to turn on this led, microcontroller will send something to this pin. Obviously it will send pin 1. Clear? Now when this microcontroller will send 1, this led will turn on. So it is very important to tell microcontroller that this pin is output pin, not input pin. And let us suppose there is a sensor, maybe let us suppose there is a temperature sensor, and if you have connected this one, for example, to any sensor. So what happened, the microcontroller will read something from this pin. So this is the input pin. So it is very important, the first step is that it is very important controller that which pin is output pin and which pin is input pin. Input pins means with respect to microcontroller, there will be some sort of signal which is coming from this pin, and output means when microcontroller will send this anything that is 10 to this pin, and from this pin microcontroller reads something. Understood? So this will be done by pin mode. Look at it. This will be done by this pin mode. So this pin mode is basically used to set any pin, here I will write pin, into mode. Mode means either input or output. I have told you. Example, look at here. So pin mode LED button, comma output. So we will connect any LED button at the output and we will initialize that one. So now let us suppose here in place of this LED button, I have written pin number 13. Let us suppose I have written this 13. So pin mode 13 comma output. Now this 13 will become the output. Understood? So our 13 will become output. So it is very important to set pin mode. Second thing, in loop, what we are going to next is digital write. So digital write is syntax that will write 1 or 0 to turn on. If you want to turn on LED, you need to send 1. So who will send? Through this syntax. Digital write means you are sending this high value to this LED button. So in place of this LED, I will write any pin. For example, I have written pin 4. So we have to connect LED at pin number 4, and whenever we will write digital write 4 comma high, this one signal will go to 4. This is the second point. So this, please, important, these are very important while we will do a programming part. Okay, next point. So next is, look at here. Okay, next. So this is the digital write. So whatever I have told you, this is the digital write. So syntax is very simple, that digital write we will initialize pin, at which pin we want to write 1 or 0. So this pin, this syntax will be used by microcontroller to send 1 or 0, right? So this is the example. So if LED is connected to pin number 12, we will write digital write 12 comma high. Okay, I am getting one message. Okay, digital write. Okay, so digital write I am explaining. Okay, let us suppose this is the microcontroller, a very simple microcontroller. Okay, and okay, I will take that slide in which the microcontroller is yeah, look at here. Okay, so I will explain digital write from here. So what happened, let us suppose I have connected one LED. Okay, now this is grounded, and let us suppose pin number 12 is connected with this LED. Now we want to turn on this LED 1. So how we can send here 1? So we will write digital write. So whenever we will write digital write of pin number 12, see, look at here, this pin number 12 comma high, yeah, 1, that means your LED will turn on. So digital write is basically, whenever we will write digital write, this microcontroller will send signal 1. And if you want to send 0, so you will send digital write 0. I think everybody understood. If anybody have any problem, okay, please tell, because we slowly we are moving towards the project part. Okay, so last 1 hour, as I have already told you, we will make project. So okay, so we will try to basic part as soon as possible. So this one. So now, okay, fine. So now I think everybody understood, and if not, so definitely in a programming part I will explain this again and again, no problem. Okay, then I think there is another pin, digital read. Please listen this one or two statement, because digital read means, digital write means sending 1 0. Digital read means listening, reading whatever coming at that pen. That's why here I have not written 1 or 0, because microcontroller cannot decide what is coming outside or from sensor. So digital read means whatever signal is sent by this sensor, we will read this one. So here I have simply write pin example. You can say that simply we will write digital read and pin. So whatever we will have that particular pin, we will read that thing. Okay, so used to read the value from digital pin. Understood? So this is basically, so again I will repeat this thing, but let's do one by one. So these are basically the very basic things which we will cover this one. Okay, now, so I have explained each and everything on this. So everything analog read, I have told you that if there is an analog pin, we will write analog pin read. We do not require this. This is the ESP8266. Okay, so before I will move toward the next part, okay, of today's session, a small description on this ESP, because a very powerful tool in case of IoT. ESP8266. So this is, you can say that, Wi-Fi module. Clear? So ESP8266 has 1, 2, 3, 4, 5, 6, 7, 8, over 8 pins. Generally, we will use only 4 pins of this ESP. Okay, rest pin we will be shorted, and also when we will make a project in which, and this will be used to, you can say that, suppose you want to connect your Arduino board with your mobile through internet. Okay, so you have to connect this ESP module in an Arduino board, and then you will be connected with the internet. So whatever the temperature or humidity will be received by that Arduino board, it will be sent to, you can say that, any, that is cloud or space. So that will make cloud, you can say that, system more efficient. So this is another sensor, temperature sensor, that we will not use today. In the tomorrow we will see the sensor, this temperature sensor. So now this is a simple. Now we are moving toward the next part. Okay, so now, so be ready for that. So now I am going to share my screen. So please be attentive. Okay, I am trying to share my screen. Wait for a few minutes because I am opening the software parts where we can make a circuit. Okay, okay, now so now again so before I will move toward the circuit, so again I will repeat the problem that we have analyzed. Okay, and okay, can you share, can you see this screen? Advait? Advait?
Yes, sir.
Okay. Screen is visible or not?
Yes, sir, visible.
Okay, fine. So let's start. So again, we will see that picture, this one. Okay. So the project that we are going to make in today's session is that, again, I am repeating that light should dim whenever there is no person. That means there should be a minimum brightness. And when the person, there is a presence, there is person around this street light, then all this lights, that is, that particular light should have a maximum brightness. Okay, so now we are, I am going to share my screen again. Okay, so okay, so now we are okay, this is the board. Okay, so now everybody can see. So this one, okay, so Advait, please confirm.
Yes, sir. Yes, sir.
Okay, okay. So if this is the board, okay, so what I am going to do again, so first of all, I will take a microcontroller part. So I will send the link of this site and you can practice any to make any circuit, and then you can make the, first of all, you can make a circuit, you can check the output, and then you can make that circuit okay, in a lab as well as. Okay, let's start. So first of all, I will that is I will open that Arduino Uno. I will select Arduino Uno. So let us suppose this is the Arduino Uno I have taken. Okay, this one. So Advait, is it okay? Speed is okay?
Yes.
Can you see the board?
Yes, sir.
Okay, okay, okay. Thank you. So now this is the Arduino board. So what the objective of today's objective is, we are going to make a project in which the street lamp should be in minimum brightness if there is no person, and it should be have maximum brightness if there is a person. Let's start. So now we have take one you can say that breadboard. Okay, breadboard which is available in the lab. Okay, so you can take that one from the lab. There is Arduino available. So if you want to make any project, okay, you can come to electronics lab. Okay, we will provide you. Okay, so this is the board. Okay, this is the breadboard. So before I will move towards the next sensor part, I will explain a little bit about the board. So these all pins, you can say that vertical pins, these pins are vertically shorted. Means whatever I will connect, okay, that any voltage we will connect at this pin, you will see that particular voltage everywhere, but only on this 5 points. Clear? This is. Now, this is the break. That means this all 5 are shorted and above this 5 are shorted. Means whatever we will connect, the value of that particular voltage you can take the first thing. Means these two segments are vertically shorted. I am getting one message and then, sir, on which source you are working? I will send everything, okay, but please focus on this. It is a very interesting project, okay. So after that, I will send on the link on the this that platform and software, whatever I am using. You can make any project, okay. So now this is the first thing. The second thing is that this part, look at here, this breadboard. This breadboard, all the pins that is in green, it is shorted. Means anything we will connect here, the voltage will be seen everywhere. Similarly, all the horizontal pins will be shorted here. Similarly, all the pins here are shorted and shorted. I think everybody understood. What? So these are sorted and these are sorted, but not both. No, these 5 are sorted and these 5 vertical sorted. So these are the vertical sorting and these are the horizontal sorting. This is the breadboard. This is Arduino Uno. We have already discussed. Okay, so this is the 5 volt, this is 3.3 volt, this is reset pin, this is ground pin. These are the analog pins through which we can have any analog value, and these are some digital pins in which we will have a 10. These are the PWM pin, means there is a pulse. The pulse will come on these pins, but whenever we will connect anything from this pin, the pulse will come. Okay, so now we are going to take another sensor, that is a ambient temperature sensor. So now I am going to take a temperature sensor. Look at it. Okay, so this is the sensor. So you can say that this is the ambient light sensor. This is a sensor that basically you can say that sense the intensity of light. uh, if we will put this into the street lamp, then what happened? So in the daytime, okay, in the daytime, uh, okay, so in the daytime, what happened? This will sense the nature light and your all bulb will be turned off. So I am going to put this sensor. So interesting point of this sensor, which is known as temperature, in an ambient light sensor, it will sense the, you can say that light, natural light, and according to that your that is bulb and whatever LED street lamp, it will be turned off. And if there is a that is light of having the less intensity, that bulb should automatically turn on with low intensity. Okay, so now I am going to see how this sensor will work. Okay, so the working of this sensor is quite easy. First of all, I will do some, you can say that connection. So first I will connect this 5 volt supply. So this is a 5 volt supply. Look at here. I am going to connect this 5 volt to this one. Look at here. So what I have did, so as I have told you at the starting that this Arduino board when turn on, it will provide 5 volt, it can provide 3.3 volt. This board, not this microcontroller, this board will provide 5 volt at this pin, 3.3 volt at this pin, but not required 3.3 volt right now because I am not going to do programming on ESP8266 module. So the point is that we are simply this using 5 volt. Now, because you know that generally the supply pin will be in red in color, so I will put this in red. Next is we are going to put a ground. So let us suppose this is the ground pin. Okay, so this is the ground pin, and look at here. So now, because you know that that ground pin, it is just a, you can say that convention, not, it is not, you can say that required, but still. So the ground is generally connected to, you can say that that is a black color, and 5 volt is connected with this one. Now what happened, uh, uh, in this you can say that whenever the Arduino will turn on, we will write a program, and whenever this Arduino will turn on, the this breadboard, that means this all points on this breadboard, that means this horizontal points will be at 5 volt, and this will be at 0 volt ground. Now, so this temperature sensor, we are going to make a project in which simply we will sense the light, and according to that, your that is bulb will turn on, street lamp. So in case of street lamp, what I am going to take, I will take a simple bulb. So look at here, this bulb. So I will take 4 bulb. So one bulb, okay, then there will be another bulb, and then there will be a third bulb, okay, and then there will be a 4, like this. Okay, now what I am going to do, I will make a project in which when this sensor will sense natural light, okay, it should remain turned off, and when we will send any light to this sensor, so this, it will turn off. Whenever there is no light on this sensor, it will be turned on. It is basically example of street lamp. So what I am going to do, the sensor has 2 terminal. Emitter will be connected with the 5 volt, and this collector will be connected to any of your, you can say that uh, let us suppose I have connected with the 8 volt. This, what I have did, I have done a very basic thing, that we have connected a temperature on this one. Okay, so signal, this signal will be on orange color. Okay, now because, and this supply, because it is coming 5 volt, so it will be red. Okay, done. Now, so this is the sensor, and then sensor is sending signal to this microcontroller, and according to this input, and that will be received by this microcontroller, this light will be controlled. This is the main task of today's class or today's session. So what I am going to do, I am you can say that making a connection of these that is bulb. Okay, so how I am going to connect, I am going to, this is 2 terminal. Okay, so we can connect this terminal. Let us suppose there is a pin number 4, okay, D4. Look at it. So we have connected this, right? And this terminal of that means this terminal is connected with we will connect this terminal by, let us suppose, because we want to turn on this one, so we will connect this one by pin number 7, because digital pin. Look at here, digital pin. So everything we are connecting with digital, okay, because we want to turn on this one, right? Okay, now, so pin number, this will be connected, we will short this terminal with this terminal. Okay, this one, wait, done. So what happened, you can rotate this to understand. You can like this, you can rotate. So now by this rotation, you can see that only one terminal is connected. Okay, so okay, so now again I am repeating. So this is the pin number terminal, and that will be shorted by this one, and similarly we will short this pin by pin terminal 1. Sorry, so wait. Okay, so I am going to short this by pin number 1, this one. Okay, now although you can see that only this terminal 1 of this valve terminal terminal 1 of this bulb, all terminals are connected with this pin number 7, right? And the terminal 1 of this bulb I have connected 4. Now you can ask, sir, why you are doing this thing? Okay, you will understand everything when we will run this program. Okay, now this terminal. So this terminal should be connected with the ground, because to make a circuit complete, we have to connect this terminal with the ground. This one, clear? So, and then we will take this, we will use a black color, this one. Similarly, this terminal is not connected. Okay, so this terminal with terminal 2 will be connected with terminal 2 of this, and then terminal 2 will also be grounded. So I will take so there is no sorting. You can see that, you can ask, sir, is there any sorting? No, because it is a software. Okay, so like this. Okay, now you, the circuit part. Okay, no, but one connection is left, so we will connect this. Okay, so I will connect this with the ground. So actually I will connect this one, and then this, and this is the ground. Now this task is over. So we have did a circuit task. So what I have did, please listen carefully. We have connected a sensor, and the sensor will send some signal at this particular pin to microcontroller. That is pin number 8 will be the input pin for this microcontroller. And according to the signal that this microcontroller will be received at pin number 8, the pin number 7 and pin number 4 will be turned on or turned, means these are the digital pin. So this microcontroller will send 1, so all the bulbs will turn on. And when this microcontroller will send 0 to these pins, all the bulbs should turn on. Clear? Now I am going to make a code. So whatever we have learned in the slides, okay, we are utilizing, and then we will run this one. So I am writing code. So in this, you can say that platform, okay, you can use a code. If you don't know the code, then you can use in a simple language, because I know I have explained the code. So I am going to write a program. So one by one we will understand, we will explain whatever we have done. Okay, so I will take my project here, okay, so that you will understand. Okay, now this one, fine. Let's start. So first what I am going to do, so this is not actually this is not my program. So what I am going to do, first step is that I am going to initialize one character. We will utilize that one. Okay, so int, so there will be a one character, and I will put this value 0. Okay, this one, light equal to 0. Now void setup, I have told you that void setup, in void setup microcontroller, that means we have to inform microcontroller that which pin is input pin and which pins are output pins. So microcontroller, according to microcontroller take data from this pin, and microcontroller send that that is information to these two pins. Okay, so for 7 and 4 will become output for this, because microcontroller will turn on these bulbs to the input, and 8 will be the input. So here I am going to write. So I am going to write here. Look at it. So in place of LED button, I will simply write pin number 4 as an output pin, because I have connected 1. And we have connected pin mode, and it will be pin number, that is, and because look at here, the 7 is also output, because microcontroller will send 1, then these bulb will turn on. So I will write pin number 7, and that is also a output pin. So use the capital letter, because there is some format of Arduino programming, so we have to follow that one. Two rules. Okay. The next part is that it is very important to tell microcontroller that pin number 8 is a input pin, then only it will start receiving signal, right? So next is that is we will you write pin, or there will be a capital M. Okay, so pin mode, and that will be pin number. So pin number 8 will be treated as input pin, and then only the microcontroller will receive the data from signal. This is the task completed. Means by this void setup, I have told this microcontroller that, okay, this is your input. Please receive data from here, and these are the output. Please send data here. Now, whatever we want to do, we will write here in a loop, and this will, you can say that, run continuously. So what I am going to do, so I am just removing this thing, okay, and I am going to make my own code. So first of all, because I have initialized the light, so we are going to read the sensor input. So for reading, we will write like light, and then equal to, and because this is the digital pin, 8 is digital, so we will write digital. So okay, and digital, there will be a read, right? Read, because we will read that whatever the value we are receiving at that particular pin, we will read. So simply here I am writing 8 and bracket close, colon. Now means, now when we will run this program, then whatever the value sent by this sensor, it will be stored in light variable. After that, we will write one condition key. If there is a brightness, if there is a natural light, that light should turn off, and there will be, if there is no, you can say that, if there is a night, so definitely the light should turn on. So for that, I am going to write that if because it is a digital, so definitely we will write and there will be a 1. So because this is the digital input, so obviously either 1 will come or 0 will come. So I have written that it is less than 1. So if this light is less than 1, so we are going to turn on. So you know that whenever light less than 1 means there is a night. Okay, so there should be a, you can say that, minimum brightness, because right now I have not introduced is the person is coming or not. So simple is that digital, right? So I am writing digital, and this will be right, and one bulb should be turned on, so we will write 4 comma, and there will be a high, and then this will be closed. And after that, the rest bulb should be turned, or you can say that all should be turned on, because after that we will introduce the person. So but right now I'm there is we are not talking about the person, so I'm simply use this, that is simply adapting the natural light. Okay, so 7 comma. So now by this way, what happens? So whenever the light intensity, or whenever the natural light brightness is less, both the all the bulbs should turn on. Else, that means if there is a proper light, okay, natural light, so what happened? Both should be turned off. So digital write. So digital write is a syntax through which you can send 1 or 0 to any pin. So here I will write low, right? And similarly, we will write, okay, so digital, and then we will write, and then 7 comma, and there will be a low value I have written. Now by this way, what happened? If there is a less light, all bulbs should turn on, that means street lamp will automatically on. If there is a, you can say that, natural daytime, so all will be off. And here I will put some delay, or you can say that better programming, so maybe millisecond, 10 millisecond delay I have written. So this task is over. Now we are in a fast way. We are going to understand that whether whatever we have done, it is okay or not. Okay. So I am smart, that is, sorry, start simulation, and let's see what happened. So I think, yes, there is no error. Look at here. Look at here. All the bulb is turned on. All the bulb is turned on. Look at here. Look at it. Okay, so now you can say, sir, so there is no light right now on this sensor, so bulb is turned on, right? Now when the intensity of light is increases, look at here, all the bulb is turned off. If understood, please write yes. Then I will move towards the next segment, in which if there is a person, then light will be controlled. On a chat box, please write yes if you understood. If there is a no light, street lamp will automatically turn on. If there is a sunlight like this, then it will be automatically bulb will turn on. So this is the one part of project that we have made, in which the light street lamps should automatically on or automatically off depending upon the sensor's output. So we will simply put one sensor. Now we are moving towards the next part. Okay, thank you. Only 7 responses I got. Okay, so students, please understand, because the program is not completed yet. Okay, so now stop writing on chat. I am going to extend this project, and we will try to complete whatever we have decided at the starting. Okay, complete solution I am giving you. So this project means it is basically you can say that street lamp will automatically turn off and turn on according to day or night, according to intensity of that is natural light. Now, if you want to make a project in which that light should be dim at night, means right now all the bulbs are turned on, means there is a high brightness. So if nobody is going on that street, but light will be there, so there is a loss of, you can say, wastage of electricity. So for that, we are going to use PIR sensor. So this is the PIR sensor, and that PIR sensor, which is known as motion sensor, as well as this motion sensor will sense the motion of any person. So what I am going to make, I will rotate this signal. So this motion sensor you will purchase from Nehru market. Okay, rupees or maybe 150 rupees, you will get this motion sensor. And whenever you will put that motion sensor, let us suppose in front of gate, so whenever this sensor will sense the presence of any person, the alarm will turn on, or maybe your light will turn on. So you can put you can make a small project in your house. Okay, so whenever the person near, then door will open like this. So now we are going to make this one. So this motion sensor has 3 signal, and then there is a ground, and then there is a power, 3 pins. Okay, so whenever you will purchase any sensor, first see the data sheet, and data sheet will tell, okay, which is the power signal. So this is the signal, means through this the signal will be received by microcontroller. But before that, it is very important, to, you can say that, connect this signal. So now what I am going to do, I am going to connect this to pin number 13. Okay, because pin number 13 is also a digital signal. So look at here, so I will directly connect it to this pin number 13. Now, because this is a signal, so I will change the color, and it will be orange, just to understand. Okay, this is the signal. So whenever the person is around this sensor, this PIR sensor will detect the presence of human body. Okay, so we can study in depth, but because it is a 2-hour session, so we cannot study in depth what it is reality, what is happening with this sensor, how this sensor will sense. There are so many things which we cannot debate because we have a very short duration. In the next time, definitely we will understand all these things. Now we are going to connect a power. So definitely you will connect this power to this 5 volt. Obviously you can connect. Now I am going to click this red. This is the power button. And now this is a ground. So ground means 0. So definitely I will connect this one with this one. And I will have a black color wire now. Okay. So now you can see that we have made you can say that a circuit in which the PIR sensor is there. Now the next task is that we have to make a program, because without program this system will not work. Okay, so when person is come, there will be some signal that will be received by microcontroller at this. So it is very important first to tell this microcontroller that pin number 13 is a input pin, because then only microcontroller will read this pin. Okay, so in that void setup we will put this pin mode. Okay, and then according to that your bulb will work. So there are two sensors, and now we are going to write a code. So let's see. So first of all, again I will slide our project in which all the components you can see. Okay, fine. So now all three sensors you can see. Now in the code, what I'm going to do, so because here we will sense the motion. So here I'm going to write that I will initialize one more variable, motion. So and initially I will initialize 0, and when the value will change, okay, definitely according to that value this sensor will send the signal. Then what happened, because this is connected to pin number 13, so it is very important to write here that pin number, that is pin number 4 or 7 was output pin, because we have to turn on bulb, but we are going to read these two pins. So here I am writing pin number. So pin mode syntax, and we are writing that is 13 comma, and here we are treating this pin as a input pin, because then only microcontroller will start reading this pin. I think those students who are understanding everything, okay, tomorrow you will see all these components practically. So PIR sensor, Arduino board, everything we will demonstrate practically, okay, using web camera. So, but today I have tried, because project is very important. So demonstration of one project I have done. Tomorrow you will see everything. Okay, in the laboratory we will show you all the component. Anyway, let's start. So now what happened? So first of all, I am going to remove all these things, because what happened? Otherwise, you will get confused. And now I am going to make up. So delay, definitely it don't have any. You can say that meaning. Simple delay means whenever the sensor will send some signal, after 10 millisecond, output will be you can see. So a simple delay means this one. Let's start. So see, before making this project, it is very important that when there is a daytime, that definitely light should turn off. But there is a night, there will be a dim light. Okay. So now what I am going to do, again same thing. If light equal, so the variable light will be whatever this sensor is sending at pin number 8. Okay, that value will be stored in light. Okay, so I am writing digital read, because without that we cannot read that uh, signal. Digital read, and simply I have written pin number, so whatever that is pin number 8. Clear? So we will connect this pin number. Okay, light equal to pin number 8, right? And now what I am going to do, after that, okay, I will remove delay as well, as because now after that we will check that whether there is a daytime or night. Okay, so or whether there is a proper light or not. So I will write if condition, and I will check that if light is less than 1. So if light is less than 1, definitely there is a night time. So definitely if there is a night, so the brightness of street lamp should be low if there is no person. So now what I am going to do, so I am going to make another read, that means motion equal to, I am going to read the you can say that the signal of this PIR sensor, right? So digital read. So I am reading this value, digital read, and pin number 13. So whatever coming at pin number 13, whatever coming at pin number 13, it will be stored in motion. Whatever coming in pin number 8, it will be stored in light. Now we will compare. If light less than 1, that means there is a night time. That means we will program like this. So because there is a night time, so now we will focus on what PIR sensor will say, if there is a person or not. So the PIR sensor, so we will read this one, and then we will put a one condition, then if. So definitely if if motion is equal to 1. What is the meaning of that? Because it is a digital read signal. This pin is digital read, means this PIR sensor either send 1 or 0. If there is a person, 1 signal will come. If there is no person, 0 signal will come. So whenever the value of motion, that means whatever it is coming, it is 1. So means there is a person, and if there is a person, what happen, all the lights should turn on. That means there should be a maximum brightness. Okay, so now how I can approach this one? So I will write 1, and then I will write digital light. All lights should turn on. So digital, and I will put this light, and that will be that means, so where we have connected the bulb, so pin number 4 and pin number 7 we have connected bulb. So that should be high. And now next is we will have digital, and that is right. All bulbs should turn on. So digital right, and here we will have that is 7, means 3 bulbs will high, means will be given 1. Else, okay, bracket close means if there is a motion, so all bulbs should turn on. That means there should be a maximum intensity of a street lamp. Otherwise else there should be a dim light, should be dim. This means only this one bulb should turn on and rest bulb should turn off. So here I am writing digital right, and in bracket only 4, that means only one bulb should be high, that should be in capital. Okay, and next, that means 3 bulbs should be low, because nobody, if there is no person detected, so obviously that we do not require 3 bulbs, should only very small, that means 1 bulb should be sufficient. So we will write that is okay, and this will be close. Now what happened, the first of all we have seen that okay, if there is a night time, so we will detect the motion, and if motion is equal to 1, then all bulb will be 1. If there is no motion else, so this will be on and rest will be off, because it is a night time. But if there is a daytime, so because we have started if condition with the night time, so if there is a daytime, so else daytime means all bulbs should be turned off, right? So we will write digital right, and that is pin number that is 4, means one bulb should be low. Okay, and next is that is pin number 7 will also be low, this one. And now we are going to close, and just to make system more not flexible, means nothing will happen suddenly. There should be some, you can say, a delay to make system, you can say that good. You can change your project. Okay, I am getting one chat. Okay, and bracket is not there. Let's see, this is the important point. If we will simulate, okay, if there is an error, definitely we will change this one. Okay, so after, if there is a bracket, and then this will be closed, so you have to say that, I think here now, so this if will be closed, else this one. I think one students have uh, okay, written that one bracket is not there. Okay, now it is okay. Okay, roll number 2, yes. Okay, thank you. So now I think the task is over. Okay, I think this should work. So first of all, it is very important to see whether this code is okay or not. So I am going to start. Okay, I am getting one message in line 5:15. Okay, one student is saying that there is a missing semicolon. Okay, right, very good, done. Now let's start simulation. Okay, now look at here. As you can see, street lamp is on minimum brightness. Only one bulb is there. Clear? Now we are going to check that. Look at here. This is the range. If you are outside, okay, that look at here. There is only if nobody in the range of, you can say that, this sensor. So obviously there will be a minimum brightness, there will be a dim, because sensor does not detect any human person. So one light will turn on, right? And the rest three will be off. That means there is a minimum brightness. But when the person will enter in this range of sensor, suddenly what happened? The street light will have a maximum brightness, right? So street light will have a maximum brightness. I hope everybody understood this point. Okay, so street light will be brightness, and when we will go outside, obviously everything will be okay. Task is over. Anyway, now what happened if there is a daytime? Look at here, I have changed this one. If there is a daytime, right? So if there is a night, only dim light will be there, because no person in the range of this PIR. And when there is a daytime, no light. So this is you can say that from my side. Okay, and now there are so many things, so many components you can have. Okay, like there is a potentiometer. Okay, a very good sensor, like there is a, you can say that, this ultrasonic sensor. And this sensor is we can make a project based on this sensor, ultrasonic sensor. This sensor, we will demonstrate tomorrow that this sensor is used to sense the distance. So we will put this sensor in a robotics eyes, as a robotics eyes. Okay, and when our robot will move, okay, so if there is an obstacle comes in that particular range, okay, so you have to study this, the data sheet of this, that is SCSR this sensor. So what happened, this sensor is just like, you can say that, eyes of robot, and you will put this one. So whenever your robot is going, and suddenly if there is an obstacle or there is a wall, and this sensor will sense the distance, and according to that we will apply the if condition, and your robot will turn right or left. Okay, so there is a, you can say that, and you can make a project that is a security, you can say that, for that is army. For army you can make a project in which there is a, if there is a you can say that person in this particular range, then you can understand, okay, that means where you have to see the army can take any decision depending upon that means the where we are installing this sensor. So similarly, to understand the humidity, there is an various sensors. So many sensors, switches, LEDs, okay, registers, okay, and then there are various wires you will have, right? Okay, hook up wire, or so those. This is, you can say that tickercad.com, there is a site. So when you will log in on this site, okay, then you can make your own circuits, you can run that circuit, and once you will run that circuit, you can make your project as well as. So if you have any doubt and if you have any question, okay, you can ask. Okay, so I have completed what we have decided in the, that is starting of this first day of workshop. So if you have any question, you can ask. Otherwise, after this session, we will send you one quiz, and you have to answer that quiz within 15 minutes, and your marks will be decided according to that, and your certificate will be provided, whatever you will get, okay, marks. So please attempt that quiz. It is important to receive a certificate. ठीक, so this is, that is it from my side. Okay, if you have any question, you can ask. Okay, otherwise after few minutes it will be ended. Advait, can you hear me?
Yes, sir.
Okay, Advait, so wait. Okay, so I think 5 minutes or 6 minutes left. So I think it will be time to send a quiz. Okay, so in your group, I am going to send a quiz. Please attempt and submit. Right?
Okay, sir.
So okay, thank you very much, and don't forget to tomorrow session, because tomorrow session, whatever we have discussed, whatever we have explained, you will see that thing in we have already made a project. Okay, so that will be beneficial for you. So when you will come in the offline mode, okay, so definitely we will conduct one session in which you will make your own project, whatever you have learned in this session. Okay, so thank you very much. Now I'm going to end this session and I'm going to send a quiz. Okay, thank you.